The scalar product or dot product of two vectors is defined as the number, the scalar, resulting from multiplying the magnitudes of the two vectors and the cosine of the angle between them. If the Cartesian components of the vectors are known, the scalar product can also be calculated this way. When the vectors are perpendicular to each other, the scalar product will be 0, because the cosine of 90 degrees equals 0. If the two vectors are parallel, the scalar product will equal the product of the vectors' magnitudes, with a positive sign if they have the same sense, since the angle is 0 in this case, and with a negative sign if they are pointing to opposite directions, since the angle equals 180 degrees in this case. The vector product or cross product of two vectors is a vector such that its magnitude is given by the result of the multiplication of the vector's magnitudes and the sine of the angle between them. Its direction is perpendicular to the plane defined by both vectors, and its pointing is given by the so-called right-hand rule. If we bend the fingers of our right hand from vector A to vector B, the thumb will indicate the pointing of vector A times B. Pay attention to the notation. The vector product is indicated by a cross, hence the name cross product, while the scalar product is represented by a dot. That's why it is also called dot product. Both symbols are not interchangeable because they indicate very different operations. The result from the vector product is a vector, while the result from the scalar product is a scalar. Be also careful not to mistake the expression for the scalar product with that of the magnitude of the vector resulting from the vector product.